Hello friends, today the topic name is anaerobic composting. Anaerobic composting is a decomposition that occurs using microorganisms that not require any oxygen to survive. In anaerobic decomposition or in anaerobic system, the majority of chemical energy content within the starting materials is released as a methane. The process is characterized by a very strong odor. Only a small amount of heat is generated, meaning is decomposition takes place much longer and it does not reach sufficient temperature to safely kill plant pathogens, weed and seeds. Anaerobic digestion process takes place in a majorly four steps. Those four steps are: one is hydrolysis, second one is acidogenesis, third one is acetogenesis, and fourth one is methanogenesis. In first stage, in a first step, what will happen? The particles and large dissolved molecules are break down into small dissolved molecules. This breaking of a small large molecules to small molecules is hydrolysis and extracellular process. And in a second step, small dissolved molecules are getting converted into acetic acid in a acidogenesis. These acetic acid plus hydrogen will getting converted into acetogenesis, and this acetic acid is getting converted into methane and carbon in a fourth step. So ultimately, in the anaerobic digestion, there will be conversion of large dissolved molecules into methane and carbon dioxide along with some water molecules. So this is the how the anaerobic digestion takes place in the process. Methods of anaerobic composting. One is in-vessel method, second one is Bangalore method. In-vessel method, it is accomplished inside an enclosed container. The whatever the decomposition takes place, it is inside the container or vessel. Different vessels are used based on the designs. So the different vessels are vertical towers, horizontal, rectangular, and circular tanks. Circular rotating tanks have been used. Major categories are plug flow and dynamic or agitated bed. So based on the mixing property, the major categories are distributed or categorized. First, the plug flow system operates on first in, first out principle. In a dynamic system, the composting metals is mixed mechanically during the process. The reason for increasing popularity of in-vessel composting are process and odor control, faster throughput, lower labor cost, and smaller area requirements as you compare with the aerobic composting. So this picture shows actually the in-vessel method how we are going to take. Okay, so this is the first type of unmixed type. So here, this is the what vertical reactor. Vertical reactor. From top, we are going to pour the processed solid waste inside the vessel. Inside the vessel. Okay. So from bottom at the initial stage to for the microbes, we are going to supply some air to adjust with the environment, and afterwards the air is taken out from the vessel to make this vessel anaerobic condition, and from top the vessel is closed. At the end of the reaction, we are going to get the compost material from the bottom. So like this the vertical tower will work same as the case in the horizontal, only the design changes there. From top we are going to pour the processed solid waste. At the initial stage we are going to supply the air. Okay, after some period, after 1 or 2 days, we are going to remove the air from the vessel. Okay, so it is left in a condition of anaerobic for some days. At the end we are going to get the compost material. So this picture shows the mixed like a dynamic flow. Okay, so the only change in the unmixed and mixed is mechanical agitator. Mechanical agitator. Here, same process. From top, we are going to pour the solid waste inside the vessel. Okay, initially the solid waste is mixed uniformly by mechanical vertical auger or agitator. Okay. At the initial stage, we are going to supply some amount of the air to accumulate or to adopt the microorganisms with the environment. And afterwards, we are going to take out the air to make this vessel anaerobic condition. It is left for some days. It is left for some days. The reaction will take place. The anaerobic digestion will take place. At the end of the process, we are going to get the compost material from the bottom. Same thing with the horizontal reactor. Only change is that the design part. Okay. Here the vertical section will take place. Here the horizontal movement will be takes place with the microorganisms as well as the solid waste. So second method is Bangalore method. In Bangalore method of composting, dry waste material of 25 centimeter thick is spread in pit and a thick suspension of cow dung in a water is sprinkled over for a moisten. A thin layer of a dry waste is laid over a moistened layer. The pit is filled alternately with a dry layer of material and cow dung suspension till it rises 0.5 meter above the ground level. It is left exposed without covering for 15 days. It is given a turning, plastered with a wet mud and left undisturbed for 5 months or till required. So this figure shows the actual how Bangalore method is done. So the pit is digged. It is covered with a sand layer. It is covered with a sand layer and alternate layer of night soil and refuse is made until it reaches the ground level. Once it is reached the ground level, it is covered with the earth surface. It is covered with the earth. It is left for at least for 3 to 4 months to make this system in anaerobic condition. So at the below of the ground level, the anaerobic decomposition will take place, and ultimately this the refuse will get converted into soil. So likewise, the Bangalore method is taken place. Design consideration for anaerobic decomposition. Size. Waste should be shredded before feeding to the reactor. So minimum the size of the solid waste should be in between 25 to 50 mm. Mixing is done, either mechanical mixing is recommended to avoid the scum buildup. Percentage of solid waste mixed with a sludge is 50% to 90% to boost up the reaction. Loading rate, it is zero point 0.6 to 1.5 kg per meter cube day. Solid concentration less than 8 to 10%, typically 4 to 8%. Temperature is around maintained 30 to 38 degrees Celsius for mesophilic reactor and 50 to 60 degree for thermophilic reactor. In this temperature, two bacteria will play main role. In 30 to 38 degrees Celsius, mesophilic bacteria will play the main role. Afterwards, 55 to 60 degree thermophilic bacteria will play the main role. Next topic is vermicomposting. Instead of using microorganisms, we are using worms to composting process. Vermicomposting is a type of composting in which certain species of earthworms are used to enhance the process of organic waste conversion and produce a better end product. It is a mesophilic process utilizing microorganisms and earthworms. Earthworms feeds the organic waste material and passes it through their digestive system and gives out a granular form of which is known as vermicompost. The chemical secretion in earthworm digestive tract help help to break down soil and organic matter. So the casting contains more nutrients that are immediately available to plants. A wide range of organic residue such as a straw, husk leaves, stalls, weeds, can etc. can be converted into vermicompost. Other potential feedstock for vermicomposting production are livestock waste, poultry litters, dairy waste, etc. Earthworm consumes organic waste and reduces the volume by 40 to 60%. Earthworm weighs about 0.5 to 0.6 gram, eats waste equivalent to its body weight. Means they'll eat waste around 0.5 to 0.6 grams and produces cost equivalent to about 50% of waste it consumes in a day. The moist content of casting ranges between 30 to 66% and the pH is around 7. The level of nutrient in compost depends upon the source of raw material and species of worms used. There are nearly 3,600 types of earthworms are there. In that, the very popular worms are red earthworms and red irregular, Acinophotia, nightcrawler, etc. The non-burrowing earthworms eat 10% of soil and 90% of organic waste material. These convert organic waste into vermicompost faster than burrowing earthworms. They can tolerate temperature ranging from 0 to 40 degrees Celsius, but the regeneration capacity is more at 20 to 30 degrees Celsius and 40 to 45% moisture level in the pile. The burrowing types of earthworms come onto the soil surface only at the night time. This makes holes in the soil up to depth of 3.5 meter and produces 5.6 kg cast by ingestion. 90% of soil and 10% of organic waste can be consumed by these burrowing earthworms. Application of vermicomposting. The vermicomposting contains higher percentage of both micro and micronutrients than garden compost. Apart from other nutrient, a fine worm cast in is rich in NPK, which are readily available form and released within a month of application. Means within a 1 month we can get a high nutrient compost. Vermicompost enhances plant growth, suppresses diseases in plants, increases porosity and microbial activity in soil, improves water retention and aeration. Vermicomposting also benefits the environment by reducing the need for chemical fertilizer and decreasing the amount of waste going to landfill. Vermicomposting production is trending up worldwide and it is finding increasing use especially in western countries, Asia Pacific and Southeast Asia. Vermicomposting may be sold in bulk or bag with a variety of compost and soil blends. Market includes home improvement centers, nurseries, landscape contractors, greenhouse and garden supply stores, grocery chains, flower shops, discount houses, and the general public users. Thank you.